Hello everyone. Myself Ananjay Pampali. I'm a student of Lovely Profession University, currently pursuing BTech in Computer Science Engineering, specialized in AI and data engineering. So today we're going to dive into the world of data structures and I'll be explaining about the queue in data structure in Python along with a real life example to show how we can implement it. So what is a queue? A queue data structure is a fundamental concept used for storing and managing data in a specific order. It follows the principle of first in, first out, where the first element added to the queue is the first one to be removed. Queue can handle multiple data. We can access both ends of the data, and also they are very fast and flexible. Elements are added to the rear of the queue and they are removed from the front of the queue. Now let's talk about some common operations you can perform on a queue. So for queue, we have the enqueue operation, dqueue, p is empty, and finally the size operation. So here the enqueue operation is used to add an element to the rear of the queue. The dqueue element is used to remove and return the elements from the front of the queue, which was added at the beginning of the queue. The peak is to return the elements at the front without removing it. The is empty is to check whether the queue is empty or not. And the size returns the number of elements in the queue. Now, since we are done with the operation, let's move on to the example. So, I'll be taking the example of 1mg, which is an online medical platform where we can consult the doctors and buy medicines online. So here we can use the queue data structure to manage the orders given by the users and handle them efficiently. So these orders need to be processed in the same order in which they were placed, like just like how the customers wait in line for their turn in their pharmacy, like they wait for a queue in their pharmacy. Now let's move on to the coding part. So let's start by defining a class queue. So this will act as a data structure. So inside this class, we will have several methods such as the init, which initializes an empty list to store our queue items. Rest are the same as I explained before, which are the enqueue, dqueue, peek, isEmpty, and the size methods. Now, before implementing this, we need to define each one of these in Python for it to be used as a code. So let's define init self self dot items. So here self is the uh, represents the instance of a class and it is used to access the different variables and methods inside the class. And init is used to initialize the class queue. Then we have define is empty, self return, then self dot items equals 0. So here if the length of the self dot items is 0, it will return true and it will show that the queue is empty. Then we have defined enqueue self dot item self dot item dot append. So this is used to add an order, like add an item into the queue. Then we have defined dqueue So if the self is empty, return none, else return self dot item dot form. So here, if the queue is empty, then there is nothing to dequeue like there's nothing to remove any item. And if it is not empty, then self dot item dot pop will remove the first items from the queue. Then we have defined p. So here is also the same as DQ. If there is nothing inside the list, then it returns none. And if there's something inside the list, then the list of items will show up. Then we have, and finally we have the defi definition of size, return len. So here we return the length of the items, which shows the number of items that are present in the current queue. Now, since we are done with defining the methods, let's move on to the actual code for maintaining the orders. So first we need to create a queue for managing the orders. So we have order queue equals queue. So this is to create the queue. Now next, when a user places an order, we have to append the item. So here we have already defined the enqueue to append an item. So order queue dot enqueue, uh, and we give the order name. So order one. So this appends order one into the queue. So similarly, let's add some more orders. So here we have three orders which are added to the queue. Next, if we have to check which order is to be processed next, we can give next order and give order queue dot peak, and we can give print next order to be processed. Then the next order which we gave above. So here when we give the peak method, it shows all the items which are there in the queue as we have defined over here. Now next, to process an order, we can give order queue, no, sorry, processed order equals order queue dot bq. Then we have print process order is, and then we can show the processed order. So here, when we give the DQ method, we like pop the item and like it is removed from the queue since it's already been processed. And next, then we can show the next order. Next order to be processed and give the next order. So here also it's the same as we have done before. It shows the next order which is to be processed after the previous order which has already been processed. Now finally uh, we can show the size of the queue, which is to print number of orders in the queue, and we can show order queue dot size. So when we run this code, this is the final output of the code. So first we are given three orders, which is order one, order two, and order three. And the next order to be processed is given as order one because order one was the first order to be placed. Then we give the processed order as order one because that is the first order in the queue. So when we process the order, that particular order is removed from the queue using the DQ method. Now, since the first order has been DQ'd, the next order to be processed is order 2 because that was the second order in the queue. And similarly, like the first one, the second order is also processed, and it goes on like that. Now, then we have number of orders in the queue is as 2 because here we have only processed one order and there were total three orders in the queue. So the remaining two orders are still in the queue. So that's why it's given two. So that's the end of the coding part. Now, giving an overview, we have created a queue class with methods like enqueue to add orders and dequeue to process and remove orders from the queue. So this Python code will stimulate the manage order processing system of 1mg. So that's all about the queue data structure, and this is how we can implement it in many situations, just like how we did it for 1mg online pharmacy. So hope you all have understood about the queue data structure from this video, and thank you for watching.